This is Olive, or Olivka, technically. She's 8 weeks old, I think. What's up? You want to say it? Hey, what's up, guys? My name is the Cherno. No? You want to say it? Hey, what's up, guys? My name is the Cherno. Welcome back to another Hazel devlog. It's been a while, hasn't it? Don't worry, I am still working on Hazel. Every time I don't post one of these videos, people assume that I've abandoned the project or disappeared somewhere or just run away. No, I'm still here. I'm still here. You're stuck with me. Amongst some stuff going on in my personal life, don't worry, nothing bad, and wanting to take a little bit of a break, as well as just taking a step back from some videos and thinking about what it is I'm actually doing with like Hazel and my life. All of this meant that there were just not many videos coming out on my channel, but hopefully we're going to be back into the swing of things starting from roundabout now. For quite a while, and I've said this before, but I've been feeling like I've been ping-ponging between two different careers, like a software engineer working on a game engine and then this kind of media video creator called the Cherno. Truth is, I'm kind of obviously both of those things, and sometimes I feel like one of those parts needs more dedication, which is why sometimes you'll see me put out more videos and do less work on Hazel. Sometimes you'll see me do more work on Hazel and put out less videos, and the latter is exactly what has happened over the last couple weeks. There are always certain things that I should be working on for Hazel. In fact, I've made a roadmap. There'll be a link to it in the description below. You can check it out. But the fact of the matter is, sometimes I get distracted by wanting to do something that I'm actually passionate about. For those of you who know me, most of my passion with computer science and programming comes from graphics. I really like graphics and rendering. And so one day, while working on what I was supposed to be working on for Hazel Dev, I thought, wouldn't this scene just look so much better with shadows? And down the rabbit hole I went. For those of you who don't know, shadows, real-time shadows, dynamic shadows, are like one of the worst things in modern rendering. Not too modern though, we're not talking about ray tracing, because that stuff is mwah. I'm talking about traditional kind of shadow mapping techniques. They are just the worst. There's no better way to describe them. Shadow mapping is just the worst, because it's not stable. It doesn't work for all cases. There's always certain things that are just a shame. It's not a proper way to actually calculate light, because the proper way, which is ray tracing, is just too expensive. You can't just bounce rays around infinitely because, well, performance. Offline rendered shadows always look better because they have time to actually compute the way that light works properly. That's why even in 2020, we still use static lighting. We still bake light maps from other software that can actually take the time to work out where the light is supposed to go and where the occlusion is, so therefore where the shadow should be. Of course, this stuff isn't just for shadows, it's for other things like ambient occlusion, global illumination, all that kind of stuff. A lot of these lighting effects are just really difficult to compute in real time without using something like ray tracing. That's why what we end up with is a whole bunch of cheat methods or approximations, and a lot of them can actually look really good until they don't. I think shadow mapping is a great example of this. You can set up a 4K shadow map, render, the light from the perspective of your scene, and in certain situations that will work really well. I mean, if you have like a spotlight and it's just got a nice little small range and you just place it there, shadow maps are fine. You're not gonna notice a huge kind of, I guess, reduction in quality there. But when you picture a huge open world, a 3D scene, and you want to have a shadow map coming in from the skylight, you want a directional light that's casting shadows upon the entire world. That's really where a lot of the problems begin. And not just problems of how on earth do I render this in enough detail and still perform adequately, but also what do I do with the edges? How do I filter them? What about self-shadowing? There's just so much. There's so much to consider. It's funny because I've never been a huge fan of shadow mapping. I specifically have avoided it for this long because I was legit, like, I'll be real with you guys. I was thinking if I give it a few years, maybe I'll just be able to ray trace it. But alas, I went down the rabbit hole of shadows. I should have just done what I was supposed to do. But sometimes the passion kicks in and you just want to make the scene look better in my case. And that's what I did. Now, the rabbit hole of shadows actually started with me being like, okay, shadow mapping is kind of, annoying. Let's do something a little bit better. What if I voxelized the whole scene and just did some cone tracing to figure out what should be in shadow, what shouldn't be in shadow, and then also get some free GI while I'm at it. This was actually one of the first things I tried. So voxelizing the whole scene, basically rendering your scene into like 3D textures and slices of voxels, essentially, that are colored and have information such as what's occluding them. That stuff is great in theory, but it also suffers from the same kind of problem that shadow maps do. Apart from being very expensive and a lot more expensive than shadow mapping, you also have the same problem of, okay, but I need all of the stuff that is around me, stuff that's close to the camera, I need to render that in a higher quality than stuff that's further away because I don't care about that as much. But what if I'm standing on a hill and looking out into the distance? I need that information to kind of be there. So what do? I can't generate an infinite amount of voxels like that. I need to make some compromises, and those same compromises need to be made for shadow mapping. So very quickly, after I think briefly implemented some kind of soft shadows with voxels, I don't even remember if I got all the way into that before I abandoned it, I realized that this probably just isn't going to be worth it, at least at this stage, and certainly not for the amount of tweaking I'm going to have to do to make it look good. So after that, I think I just went with some pretty simple hard shadows. This is cool. This is feeling like an actual development log. I'm actually going over what I did in the last 2 weeks in my whole journey. Let me know if you guys are interested more in this kind of stuff. I looked through so many different shadow mapping techniques. I mean, I started with just normal kind of PCF filtering. I think I went to variance shadow maps after that, and then exponential shadow maps after that. There's just so many different names, and they all mean almost nothing unless you actually look up what the algorithm does. What does variance shadow mapping mean? I think I ultimately realized that I did want soft shadows, but I didn't just want kind of like make all my shadows soft no matter what, because that doesn't really look very realistic. I wanted actual kind of almost like contact hardening shadows that the closer you are to the surface, the harder the shadow is, because that's how the real world works, and I think that's one of the coolest things that you can actually implement. I think it almost immediately makes your scene look a lot better, especially to someone who knows what they're looking at. So for that, I stumbled upon 2 different NVIDIA algorithms, and I think one of them is like 15 years old and the other one is a little bit newer. So PCSS, which is percentage closer soft shadows, and then also hybrid frustum soft shadows, I think. Hybrid frustum traced shadows, which is basically where you do like ray tracing with the shadows, but it's like with a frustum or with triangles or something like that. I don't know. I didn't look into it too much because it was, as far as I could tell, there weren't really that many open source implementations, because it is part of NVIDIA GameWorks, which is like a third-party middleware, and then also it's extremely expensive. I think it just pretty much takes up like 90% of your render time or something ridiculous. It was just way too expensive. I wanted something that would perform decently. So I went back to PCSS. Now, NVIDIA has a really cool paper on this from like 2005, but let's be real, reading papers and implementing algorithms by yourself in 2020 is a little bit of a drag, unless it's like a cutting edge new algorithm that no one has ever implemented and you're like, well, I guess I have to. Don't get me wrong, I love reading papers, and I think that it's extremely important to actually read a paper to figure out what you're dealing with. But the next step should be to go to GitHub and see if you can find some example code. If you can find someone's implementation, that is a fantastic starting point. Now notice how I said starting point. That's because almost nothing, at least in my experience, that I found on GitHub was just perfect out of the box. I mean, don't get me wrong, people have made some really nice implementations of PCSS. Some of them look better than others. Some of them do things differently. Some of them, for example, do the penumbra calculation and the blocker kind of, finding the blockers of what occludes the light and all of that stuff. Some of them do that better than others. Some of them do the actual filtering a bit differently or better. Some of them are implemented in not a very good kind of performing way. Some of them are more optimized. There's just, with the open source community, there's so much stuff out there. And I think that it's really nice to be able to look at existing code, but then you have to look at it as someone has just put this on GitHub. I don't know who it is. I don't know what kind of quality of software this is going to be. It's just on GitHub. That's great. It's going to be a huge help to me most likely, but I'm going to have to probably just change it quite a bit. It's a lot easier than trying to implement an algorithm from a paper with absolutely no reference whatsoever, and it's a lot faster than that as well. But I think gone are the days where I could just copy and paste some code, slap it in, and then everything just works out of the box and everything is perfect. There's usually a lot of tweaking or rewriting or optimizing that needs to be done. So I think in the end, I ended up looking at 3 or 4 different PCSS implementations on GitHub and kind of almost like vocal comping, where a singer like records like a vocal track and then you pick the best parts of everything and you kind of composite it together. Almost like that. I kind of just picked someone's blocker search implementation was fantastic. Someone's filtering implementation was fantastic. I threw in some of my own code as well to make some things a little bit faster and just look a little bit nicer. And I think at that point I got something that was looking decent. I mean, I probably spent almost a day going through a lot of different shadow mapping algorithms on GitHub, downloading the sample projects, compiling them, looking at them and being like, oh, this doesn't look good at all. But then finally, with a little bit of playing with it and actually understanding how the algorithm works so I can, modify it and fix it in some cases, I finally got to the point where I was really quite happy with the result. Except for the fact that all of the algorithms that I looked at were understandably just lighting a little like model or a sphere or a cube on a plane. That's it. So this isn't like some 3D world, like an open world, that is fully just perfect, like shadow solution for a perfect open 3D world of infinite scale. No, this really only worked for your kind of model, for like a model viewer, essentially. And this is something that I see a lot. Lots of people who are writing their own engines or their own games will kind of maybe get to the point where they start relying on like people's code off GitHub a little bit too much, because everything is so available, right? Why wouldn't you just download someone's code from GitHub, slap it in, and everything's going to work perfectly? The thing is, almost none of the samples that you find are scalable, meaning that more than likely they're set up to just demo an algorithm or demo a sample in one of the simplest cases. And that's why almost all of the samples you find online are just like essentially a model viewer. There's just like some, physically based rendering, sure, but it's like one model in the middle of the screen and maybe like a ground plane or something. That's it. That's not a game. That's not a scene. Writing a game engine that can render an entire scene that you can walk around and interact with and run across, that is a completely different story to looking at like Sasha Willems' Vulkan examples and being like, this is how you write a Vulkan renderer. Absolutely no disrespect to Sasha Willems, by the way. Those examples are mint, but they're just not really examples of like a scalable game engine, which is understandable. They're not supposed to be. Oh man, I haven't made a video in so long. I just feel like talking for hours. Anyway, I'm sorry. Let's get back to the shadow stuff. So long story short, all of the shadow mapping examples I looked at and the way that they were set up was just to render a single model. But obviously I need to be able to render a whole scene. I need to be able to render a world that you can run across, and wherever you are, you should see shadows. It should work all across the world. Now, a really popular way to handle that is something called cascaded shadow mapping. So what that means is that instead of rendering a single shadow map and you kind of try and, position the shadow map in a way that fits your scene, instead of doing that, you render 3 or 4 or potentially more different shadow maps from increasingly further out angles. And it's not just really increasingly further out angles, but basically what you do is you divide the camera's frustum, so whatever the camera is looking at, into like 3 or 4 pieces, and then starting with the section that is closest to what the camera is looking at, closest to the camera, and then going increasingly further and further away. Now what that allows you to do is basically zoom in your shadow rendering into the part that's kind of closest to the camera, and then for the stuff that's further away, you use a kind of less detailed, more zoomed out kind of shadow map, because obviously a frustum, the stuff that's closest to the camera is the biggest, it's what you're looking at, it's physically bigger, and then the further away from the camera you get, the more stuff fits onto the screen, so therefore you kind of need to render a larger shadow map, but you don't want to, because if you do that, then you'll lose detail. For someone who's never implemented shadow mapping, this probably doesn't make much sense, but just bear with me. And then also, instead of just being like, this is my directional light, I'm going to focus it at, the origin of the world and just render my shadow map there, you also need to move everything with the camera, because there's no point in rendering like part of a shadow map that is, behind the camera. You're never going to use that. You essentially want to move the shadow map rendering with the camera. So I had to take all of the PCSS stuff that I did and then add shadow cascades to that, and then also make it kind of fit the camera's frustum so that we could look around and, wherever we were, we would see shadows, and also implement some kind of shadow distance. And I ended up doing a lot of tweaking and a lot of extra implementation on top of all of this to actually make the shadows look as good as possible. And still, they're nowhere near done, and I'm just going to kind of move off of this for now, because it's taking too much time. I need to do other stuff, unfortunately. I can't do shadows full time, but for now I think they're fine. I've kept the option for hard shadows as well, just in case you want that extra performance. But overall, it was a super fun 2 weeks. I did a little bit of live streaming yesterday as well on twitch.tv/thecherno, where I kind of spent some time refining the shadow mapping and just making it a little bit better, just tweaking the shaders, all of that kind of stuff. And I think it's finally gotten to the point where I feel comfortable showing you guys. Now, that's another thing that I've been thinking about a lot. These are devlogs. I probably should show my shadow mapping failing as well, because if I just show everything being good and you don't see the hours of me pulling my hair out, then maybe that's not a good look for what it's really like to build a game engine. Believe me, it's not all rainbows and butterflies. But anyway, let's jump in to Hazel and we'll take a look at that. Also, I've added some other I've added light components, or at least a directional light component. I added something called a skylight. You know, well, I'll show you what I'm talking about, but we might revisit this stuff in a later episode as well in more detail. Okay, so opening up Hazelnut, we are greeted with this kind of black scene. It's got a very simple entity here that has a kind of a scene model. It's like this box and then like another box on top of it, and there's also a sphere in the scene that is actually quite small. So this scene at the moment has no lighting. I've revamped the entire lighting system, so if there are no lights, this is what you see. Now in the future there might be some kind of like editor lighting situation, but this is essentially, pretend that the lighting for this is runtime lighting. Even though we're using an editor camera and we don't actually have a camera entity in our scene, the lighting is still being calculated, I guess, as if it was completely done as part of the runtime. So we need to add some lights. So there are two different types of lights here. I've created like a bit of a better context menu so that we don't have to create an empty entity and then add all the components to it. So we have two at the moment. We've got a directional light and a skylight. Now, a directional light is what you might expect. It's just a directional light, and this is what it looks like. These are the default shadow settings, and this is what you see, and we'll go into more depth about that in a minute. But then you've also got a skylight. Now this, I kind of took inspiration from Unreal Engine because I needed somewhere to put my IBL, my kind of environment map. And I noticed that they do it by essentially just creating a skylight, and then you can set like an environment map in there. So if I create a new skylight, and then open up a environment map, like Birchwood, for example, it's an HDR file. This is what our scene now looks like with both a skylight and a directional light. Now you can remove the directional light, and then this is just going to be ambient lighting from the skylight, no directional light at all. And as we don't have any kind of like ambient occlusion or anything like that, there's not going to be any kind of shading or shadows whatsoever. Okay, let's create the directional light back, and this is what the scene looks like. Now it's looking a little bit bright. There's a few reasons for this, and there's a few ways that you can control this. The skylight actually has an intensity. This is like the contribution multiplier, I guess, of the actual IBL calculation for the PBR shader. So you can actually just drop that to 0, and now it won't contribute any IBL. This is as if we just removed the skylight altogether. And then we can kind of add a little bit maybe, and obviously add a lot if we want to as well. So that's one way that we can play around with that. But then also we have a camera exposure. Since this is not the actual runtime scene with the camera entity, the environment panel at the moment has a few controls that are specific to the actual kind of scene editor camera. So I can just drop the exposure a little bit, and then you'll see that we won't be quite so overexposed. So this is kind of what the scene looks like. Now, one thing that I forgot to add before this video actually into the directional light properties was the color or the radiance of the light. So there used to be like a light radiance here that at the moment does nothing. So I forgot to add that, but anyway, it doesn't matter. There'll be a light radiance there. And in fact, all of this obviously is very much work in progress, so I'm going to be tweaking this a lot. So we have a few options for the directional light. Obviously we can control the direction, and that's as simple as just opening up the gizmo or playing with the transformation of the light in general. But then also we have cast shadows, soft shadows, and source size. I believe these two don't do anything at the moment because they're controlled globally, as we'll see in a minute. But cast shadows, of course, will either cast shadows or not cast shadows. Let's make this a little bit bigger maybe and move it somewhere else, and then we can see the result of enabling shadows and not. So let's talk a little bit about the different shadow types that we have. So if I open up this temporary scene renderer panel, I guess, which just contains some exposed variables and like the shadow map texture as well from the scene renderer, we have soft shadows and hard shadows. So there is a bit of a performance difference. Where's my little performance thing? Here it is. So if I bring this over here, it just says how many milliseconds we have per frame, and I've turned VSync off, of course. So soft shadows is, you can see 3 to 4 milliseconds for this scene, and then if I turn that off, it's quite a bit faster, 0.8 or so milliseconds with hard shadows. So that's just something to keep in mind. Soft shadows will cost more, of course. And we have a few kind of parameters here that you can tweak. So light size is a good example. If I just drop this to 0, then it's basically hard shadows. Hard shadows that cost the same as soft shadows. So if I kind of enable that and disable that, at the moment, the way that the shader works is they look identical, but this one costs a lot more performance. So if you're after this kind of look, then shut off soft shadows, and this is something that you'll be able to do per light in the future. So yeah, if we obviously increase that, you can see that the shadow gets more and more soft. I think 0.5, 0.25 is probably a good kind of amount, and you can always tweak that per light as well in the future. So it's something that probably, maybe I'll change the way that the sampling works, because obviously if we have a softer light, we need more samples than if we have a harder light, because there's just, you can get away with doing less samples since there's just not that much of an area. So let me quickly add just a mesh here. I'll add and at the moment, even if we're loading just a simple cube, we still have to kind of load it like that. So if I move this over here, this will demonstrate what I was talking about the fact that the light will be softer based on how far away the object is from the surface. So if we kind of move this down a little bit, you should be able to see, this is a terrible position for it, isn't it? That the light or the shadow that is closer to the actual, you know, where this, I guess, object actually hits. Okay, that was a terrible explanation. The closer the object is to the shadow, the harder the shadow is. So as I move over here, you can see the shadow gets progressively softer, which is exactly the effect that we're after. Obviously with hard shadows, we don't have anything like that whatsoever, and it just looks hard everywhere, which is fine. I mean, a lot of games look like that, and it's totally okay. But these days, of course, we're more used to seeing graphics like this. So I mentioned cascaded shadow mapping. I'm not going to get too much into this, but you can see that we have different cascades, and this is, if we visualize them, it just paints them a different color. It just tints the scene a different color based on what cascade we're at. So the first one is red. We can also browse through all of the shadow maps here. You can play with like the split of the cascades. So this is like a little bit of a function or a variable that goes into a function to determine what the split should be like. I think 0.91 was a good value that I decided to stick with. And one thing you'll also notice is that the seams between the cascades are pretty good. I mean, if you focus in on this area here, like I can't even tell the difference. And this was actually something I worked on completely in the live stream I did yesterday. So if you're interested in catching me developing things like that, the live stream is a really good place to see me actually work. And in fact, lately I've been posting some of the development work I've been doing for Hazel on Twitter as well. So for example, last night I decided to see if I could quickly get like a depth of field effect in there, and I posted like a little video of that to Twitter. So definitely follow me on Twitter at the Cherno if you want to keep up like with I guess smaller updates instead of kind of waiting for these devlog videos to come out. Anyway, I think that's pretty much it. Oh yeah, so there's also a max shadow distance. So if I eventually get too far away, you'll see the shadows kind of fade out. And obviously the reason that exists is because eventually we'll be at the last cascade and they'll just, you know, we can't keep getting further away and still have shadows of the same quality. And so it might be more preferable to just fade them out. This is something that you can definitely tweak here. And so if I bring this way down, for example, to like here, you can see that they fade out a lot faster. In fact, I might even bring that in more. And then you can also control the amount of fade. So you can see 25 is quite a long kind of fade. But if you bring that down to like, I don't know, 1 or something, it'll obviously be quite a hard cutoff. Even 1 doesn't look too bad. I think 0 is quite a hard cutoff. It's just a line. But then if you maybe do 2 or something, that might be a little bit better. And you can see we have like this kind of soft transition to when we no longer have shadows. So yeah, that is dynamic shadows in our scene. It's pretty cool, I think. It's just the beginning. As I mentioned, there's a lot of different kind of artifacts and stuff that doesn't really quite work very well. This cube, by the way, is I think a little bit messed up because you can see that I think the faces are facing the wrong way or something. Because the shadow doesn't really get cast on it correctly. I imagine that that looks a bit different. Also, this stuff is still, of course, very raw and very unoptimized. There's still plenty of work to be done to make it a lot better. Oh, and one more thing I'll do, I'll load a slightly better looking mesh, because it'll be nicer, I think, to see something that isn't just a sphere or a cube. And then we can see what that looks like. Wow, that's big. All right, let's scale that down. And maybe I'll just scale this up. And let me bring back my max shadow distance. Okay, bring that down. So yeah, now we have something, I guess, a little bit more interesting in the scene that's also casting shadows. just rotate my directional light a little bit differently. So yeah, pretty exciting stuff. Alright, hope you guys enjoyed this video. If you did, please don't forget to hit the like button. Let me know what you thought of this devlog in the comments below. I did go a little bit more in depth than usual, so I hope the video wasn't too long. Just let me know in general, because obviously I'm trying to make these devlogs as good as possible for you guys to watch and as enjoyable as possible. If you want to help support Hazel, don't forget to go to patreon.com/thecherno. You'll get access to this source code. What you just saw right now, you'll be able to download it, take a look at my implementation, play around with it, break it, tell me how bad it is, etc. And also catch all of the backlog of live streams of me working on this kind of stuff. I didn't stream this stuff too much, but I definitely want to going forward. Huge thank you to all of you for your wonderful support. I will see you next time. Goodbye.